All right, my friends, one thing I really like about the comparison test and the limit comparison test is that you don't really have to know which test you're going to use at the very beginning. You can just kind of start, saying compare to, you don't have to know at the very beginning which type you're comparing, which test you're going to use. So let's think this out. So what would I compare it to? So I personally find that +4 horribly inconvenient. And so this is what I would choose to compare it to. And then I'll simplify that. So that would be 3 times the sum as n goes from 3 to infinity of 1 over n, if I simplify that. So what do I know about this? So 1 over n, the sum of all the 1 over n's, that's the harmonic series. It's also a p series. Either way, that sucker diverges. And so which is... you could say which is the harmonic series, or you could just say which is a divergent p series. For some reason, I find that a little bit easier to explain. So that's the one I tend to use. So, and then in parentheses, I would say my p-value is 1. So I know that this diverges. So now let's think like about just comparison test. So if we are saying that this one right here diverges, so it does not go to 0 fast enough to add up to something finite, which means in order for the logic for comparison test to make sense, we would need these terms to be above. There we go. Anyway, and they're not above, they're below because you're dividing by a bigger number. There we go. Okay. So that means logic doesn't hold for regular comparison test. So we'll just try limit comparison test instead, right? So if comparison test says no, then see if limit comparison test says yes. So furthermore, let's look at the limit as n approaches infinity of the one that we started out with, 3 over the square root of n squared plus 4 divided by the one that we're comparing it to. Okay, and up to you which version of, whether you like the simplified one or the pre-simplified one. For this particular one, I kind of like the pre-simplified one, and here's why. So then let's flip and multiply. The 3's will cancel out, so we'd end up with the limit as n approaches infinity of square root of n squared, which, yes, that's just n, over square root of n squared plus 4. And the reason I liked that kind of pre-simplified version for this one is because then what I could do is I could just put everything underneath the square root. And for me, it makes it a little bit easier to see that I'm definitely going to get 1 for this one. So you could just, imagine letting n go to infinity, and, the value on the top is basically the same as the value on the bottom. You could use L'Hopital's rule. You could use that fun 1 over n, multiplying by 1 over n over 1 over n trick. So many ways. I'm going to assume you have a way to figure out that this would equal 1. And the point is that it is finite and positive. And so, according to the limit comparison test, we would say that the sum as n goes from 3 to infinity of 3 over square root of n squared plus 4 also diverges by the limit comparison test. Okay, do you need to write all this out? Yes, you do. It would be a tragedy for you to get through the notes for this lesson and the problem set for this lesson and minimize the amount of work you do on each problem and then end up being completely underprepared for your AP exam. So it is the writing and the steps and using actual sentences in math and saying which test you used and kind of defending your logic that will get you ready for your AP exam. Just saying the answer won't accomplish that at all. Okay, now before we quit on this one, I do want to make sure that we show that you won't always get 1 here, that truly anything finite and positive would work, okay? And so, for example, let's say for this problem, I decided to compare it to, instead of a 3, let's say I wanted to put a 1 there. And so I would still have something that I'm still comparing it to something that diverges without the 3 there. And then when I do my work here, I just wouldn't have a 3 here. I'd have a 1. And then when I flipped and multiplied, I would have ended up, oopsie, sorry. I would have ended up with a 3 here that didn't cancel out. And so, and that 3 could have come up front. And then I wouldn't have gotten 1, I would have gotten 3, which is still something finite and positive. And so my conclusion would have still been the same. So I wanted to make sure I do have a tendency, because of the way I do them, to always get 1 for my limit value, or usually get 1, but it doesn't have to be 1. Anything finite or positive for this particular test would work. There we go. All right, my friends. So now that you have that down, one thing I want to do is make sure you have some practice with mixed review, so that you can be ready for getting to the end of the chapter, or getting to your AP exam, and you're expected to kind of know a little bit of everything at the same time. Okay. So for the mixed review, let's have you give these problems a shot, and then do your best on it, and then check in with me in the next video. Good luck.